treated, that is called as an diathermy. So what is known as diathermy? Diathermy is nothing but any area of the human body that can be treated by applying the heating. So how here the heat that we are going to produce? So the heat is nothing but just like by applying a hot towel. That is our traditional treatment, that whenever we have swelling, that is our ancestors or grandmother, they can be treated just by applying hot towel over that, which means that is the heat now can be transferred to the human, that is tissue. So that is the basic concept here. But always what happens whenever we apply a hot towel or any hot material over the human body muscles or tissues, that is the area, that is it can be burned based on the application of the heating. If the heat is more, for example, that is with the help of the hot towel, when we are going to apply over a swelling, if the heat is more, that is in the muscle, that is the tissue can get burned because of it is an overheat. So that is such technique may not be able to suitable for all applications, or that is we may not be able to know what is the amount of heat that can be able to provide to the human body tissue, and it also depend on the area to be treated. So sometimes the overlying muscles needs to be treated, or sometimes whenever we have that is some injuries in the bone level or deeper lying tissue level, that is we may not be able to know that the application of the hot towel will transfer the heat to the underlying tissue or not. So because of these drawbacks, we need some electronic equipment to apply a heat. So that is electronic setup for the application of an heat. So how the heat can be generally provided? That is, as an electronic engineer, we are familiar with what? We are familiar with, that is either voltage or otherwise an current only. Only these are the two things. That is either we can apply in the form of an voltage or otherwise an current. But when we are going to apply an voltage and then current straight away to the human body, what will happen? There will be a tissue destruction. So that is the tissue may get damaged, or otherwise when we apply a certain voltage and then a current to the human body, it can be act like a stimulus. So that is when we apply a few voltage to the human muscle, it can act as a stimulus, which means because of these stimulus, there will be a muscle contraction. So there will be a muscle contraction. Moreover, that is because of it act as a stimulus, sometimes it may stimulate the sensory and as well as the motor nerves. So how to provide the heat is a big question here. So instead of applying a voltage and then current straight away to the human body tissue or muscles, here we are going to utilize a high frequency current. So the high frequency current always will decide. So high frequency means either that is high frequency current means it can be an alternating current. So alternating only can provide the amount of the frequency only. So the high frequency here it is the alternating current. Here we are going to apply to the human body. So it may contain any frequency. It may be low like this, or sometimes it may be an high. So depend on the low and then high, the amount of current applied to the tissue, it will decide the depth. So high frequency current will provide the heat to the deeper lying tissues. So that is why here instead of applying just straight away voltage and current to the human body, we are choosing a high frequency current. Okay. So this high frequency current are basically here can provide by means of any, that is the high frequency means high means in terms of what, whether it is in terms of the kilo, that is kilohertz or megahertz or simply an hertz. So it depends on the amount of that is high frequency. Now the diathermy techniques are classified it into three types. So first one is an shortwave diathermy, the second one is microwave diathermy, and then the third technique is an ultrasonic diathermy. So here that is already we said the amount of high frequency current. So based on the amount of high frequency current, it is divided it into three. So short wave means what? The shorter frequency range. Shorter frequency range, which is nothing but compared to the compared to all these diathermy techniques, this has a low frequency range. So that frequency range here it is 27.15 megahertz with a wavelength of here it is an 11 meter. So that is the frequency range generally can be used for the shortwave diathermy. So the next is the microwave diathermy. So which means the high frequency amount of current we are giving it in the microwave frequency ranges. So since it is a microwave frequency ranges, it is also megahertz, but compared to shorter wave, here it is slightly higher. So that higher is it can be varied from 300 megahertz to 300,000 megahertz, which can have the, that is wavelength maximum is 12.25 centimeter. Okay, sorry, 10 mm to 1 m, which can cover the distance of 12.25 centimeter. Then the next is the ultrasonic. So here the frequency range is in the UHF frequency range, that is ultrasonic high frequency range. So mostly this is for the treatment of the bones and then deeper tissues. These are the that is ultrasonic type of diathermy wave can be used. Okay. So diathermy is nothing but through heating something can be treated is called as an diathermy. So the heat generally can be applied in the form of using the hot towel. So what will happen when we apply a hot towel over the muscles, that is the muscles may get burned so that there will be a tissue destruction. So what will happen? So we are trying to find out the alternate method, that is the latest with the help of an electronic technology. So we are going for an electronic equipment for the application of heat. So when we are going to apply the heat with the help of the electronic, it can be done only with either voltage or current. But when we apply some voltage or current to the human body, what will happen? Sometimes it may stimulate sensory or motor nerve. Sometimes it may stimulate the muscle contraction. So that is the heating now can be provided with the help of the application of some high frequency current only. So the high frequency it can be varied from say some kilohertz to megahertz range, or even the ultra high frequency ranges also. So depend on the amount of how much amount of high frequency here it is provided, that is the area to be treated can be increased. So based on the amount of the high frequency we provided, basically diathermy techniques are divided it into three. So shortwave, microwave, ultrasonic. Shortwave frequency range is 27.15 megahertz with the wavelength of 11 meter. Similarly for the microwave 300 to 300,000 megahertz, which can cover the distance of the area to be treated is up to 12.25 centimeter. Similarly, the ultra high frequency range, if we generate for treating the area to be treated is called or known as an ultrasonic diathermy unit. So let us see now one by one in detail, that is how a short wave or microwave or ultrasonic wave can be generated, and then how it can be applied to the human tissue for treating the particular area or a region. So first, short wave. So first, in the shortwave diathermy, the most important thing is an production of an shortwave. So production of shortwave. So the first diathermy unit which was established is the one as the shortwave diathermy unit only. So in the production of the shortwave, what type of that electronic circuit that we used? So here in the production of the shortwave, the electronic circuit here it is consists of the two parts. So one is an that is RF frequency circuit. The other one is an patient circuit. So which consists of two circuits basically. So one circuit which is used to generate a high frequency current. So the other circuit is called as an patient circuit or resonator circuit, which is just used to transfer the high frequency current to the subject. So how these circuits are constructed basically. So because of this is the type of the diathermy which was established when the electronic comes. So initially these circuits are constructed with the triodes only. So not with diodes and then transistors and then the large scale technologies, ICs. So because of it is constructed with the first electronic advancement, these are constructed mainly with the triodes only. So triodes means here it may consist of anode and as well as the cathode. So by that is energizing the anode and as well as the cathode voltages, we can able to produce a very high current. So first let us take the circuit. So here in the shortwave diathermy circuit, so first initially the supply is taken from the main. So this supply is a standard supply. So that is 230 volt AC only. So in order to produce a short wave, which means short wave frequency range, already I said it is a 27.15 megahertz range. So in order to generate this amount of high frequency current, we require a high amount of voltage. So that is here with the help of the transformer 1. So it is a step up transformer first. Step up transformer. Now with the help of this the voltage is increased. So what is the amount of this maximum voltage here it is, and that is in order to produce this 27.15 megahertz high frequency current, that is the anode here it is required some 4000 volt. So a high step up transformer here it is used to increase from the 230 volt main to 4000 volt. So here it is separated with winding. So here that is the upper winding here are used to energize your anode. Okay. Then the next that is the other part of the circuit. So here it is anode and then this is the cathode. That is the cathode voltage is provided by the secondary transformer T2. Okay. So here because of we provided a high amount of voltage, so whenever that is the electron move from anode to cathode, there is a production of an that is current, that is high frequency current. So high frequency current how we can have for this high amount of voltage, there are more number of that is electrons can move from here and there. Okay. So in order to capture this, here also we require a high amount of voltage. So now the cathode voltage now can be provided by the secondary of the transformer T2, that is with AB. But this AB along with the C1, that is provide the effect of the that is tank circuit. Okay, provide the effect of tank circuit. So we know what is the function of the tank circuit. So the tank circuit is nothing but generally an LC circuit. So here it is an LC. So what will happen, because of anode and then cathode is connected with a high amount of voltage. So now here that is the electron can move, that is because of the drift operation. So which is being now captured, okay, that particular voltage now being captured and then used for these LC circuits. So what will happen, based on the voltage, now this LC circuit will produce a alternating current, okay, that is a high frequency current. And then, so what is the purpose of having this CD is nothing but, CD is also another coil. So there is some few amount of voltage. This few amount of voltage here it is used for heating the filament only. Okay. So now heating the filament is also essential. Then only that is there is a conductivity in this triode wall can happen. So that here for heating the filament the coil CD here it is used. And then the purpose of having a resistance. So here the one resistance, that is change in resistance, which is connected in series. So it is mainly to adjust your grid bias. So how we can able to control the high frequency amount? There are variety of possibility in the case of shortwave diathermy. One thing is just first by adjusting the anode voltage. Then second one is by adjusting the grid bias. Then the third one is that is by filament heating. So these are the three. So these are the three ways that we can able to adjust the amount of the high frequency current. But even though there are three ways, that is which is suitable or which is best is always just by adjusting the grid bias only. Why? Because if you want to adjust the anode voltage and as well as heating the filament, that is here the voltage must be adjusted. Okay. So because of it is a high unit and then working with an EHT, so it that is adjusting the anode voltage and then heating filament is little bit difficult. So that just by adjusting the grid bias, we can able to control the amount of high frequency current. Here it is produced by the short wave. Then apart from this tank circuit, so this tank circuit is an oscillator circuit. Now what happened, based on the voltage here it is produced by the triode valve. Now the high frequency current here can be produced. Now this high frequency current produced by this circuit has to be transferred to the subject. So in order to transfer to the subject, here the another, that is circuit. So one is a coil EF with capacitor C2. So this is also another form, again a tank circuit. So now what is the purpose of the EF? Here it is EF and CD here both form one, again a transformer. So which means there will be a transformer induced EMF. So what will happen? That is the feedback to the main. Okay, so provide the feedback. So here the LC circuit form an oscillator. So oscillator consists of an feedback. So the type of the feedback here it is a positive feedback. So in order to provide the positive feedback, this CD and then EF here it is formed. And with the help of the, by adjusting the capacitor. So based on the, if you adjust the capacitor, the voltage across the capacitor here now can be going to vary, because of which is driven from here. So driven from here, abhina, from this end. That is what is your LC circuit produced a voltage that is now being transferred here, which can be applied to the subject via your capacitor. So then, why here there is a change in capacitance here it is required is because of the amount of heat to be applied to the subject is depend on the area to be treated. So according to the area, that is the amount of heat has to be controlled over. That can also be here controlled with the help of by adjusting the capacitor. And with the, but even though we adjusted, there is a tuning indicator is there. So the tuning indicator can indicate that is the maximum tuning and as well as the minimum just by drifting either to this side or otherwise on this side only. So the amount of tuning. Then after that, with the help of the two electrodes which are basically driven from this point and then applied to a subject. So now with the help of this circuit, how the short wave here it is produced, that short wave now being transferred to the patient circuit. So this is main circuit which consists of T1 AB with C. So that is the circuit which is used to generate the high frequency current, and then patient circuit here it is nothing but a coil EF and then C2, because which is used to supply the same amount of the short wave to the subject. So this is here it is called as an patient circuit. So now even though here we have chosen the two electrodes, how are we going to apply to the human subjects? So that is what we are going to see now. Before that, here the tuning is very essential, because the tuning is nothing but gives dosage control. So dosage control is nothing but the amount of heat only. So sometimes or when we are at the beginning of the treatment stage, maybe less amount of heat required, less amount of heat. So once we started to apply, that is the patient may be able to withstand some amount of heat, so that we can increase the amount of heat later. So this is here now called as a dosage. So that dosage control here, it is nothing but can be indicated only, can be adjusted with the help of manually, either by adjusting the capacitor or otherwise the filament voltage or otherwise the anode voltage, so on. So all these things here are being done, that is with the help of manually only. So manual control is not advisable, because that is, suppose where there is a low dosage is required, that is wrongly, if the physician or the particular attendant, if you apply a higher dosage, that is tissue damage may happen. Even sometimes it can be extended up to even the damage of the bones also. So that always here the tuning should be done automatically. That is, automatic tuning is required. So how these automatic tuning circuit? So this is one additional, that is RF circuit only, RF circuit along with a capacitor. So based on the capacitor amount of voltage, that is the RF frequency generation is going to be varied. So this capacitor voltage is nothing but being controlled, or it is being sensed from the patient area. So அவங்களோட ஏரியால, that is how much amount of voltage, accordingly that the particular RF circuit can be tuned, so that here the automatic tuning can also be possible. So if you want to have automatic tuning, one additional RF circuit along with the capacitor is enough. Okay. So now the next, how we are going to apply a short wave. So apply short wave. The short wave can be applied to the subject with the help of the two electrodes by two different methods. So one is an capacitor method, the other one is an inductor method. So what is known as this capacitor and as well as an inductor method is, that is how we are going to place these two electrodes to the human subject. Accordingly, it is named as a capacitor method and then inductor method. So in the case of an capacitor method, that is the two electrodes, which means that is these 2 points driven from this circuit are connected with a metal plate only. So now this is the area to be treated. Say this is the bone, this is the area to be treated. So now what will happen? These are the two electrodes, that is the electrode points actually. So this is the electrode points. So when we are going to place on either side of the area to be treated, now what will happen? The two metal plate electrodes form a capacitance effect. So which means two parallel plates that we have placed. That is what means here. So whenever the two parallel plates are formed, that there will be a capacitance effect. So the capacitance effect, there may be a dielectric loss. So the dielectric loss here can be applied as a heat to the particular area. So that is why this method is called as an capacitance method, or otherwise it is called as an condenser method. So in the condenser method, we can also place the electrodes even side by side. So here it is represented with opposite side. That is, here the area to be treated, the opposite side two metal plate electrodes we have kept. So the next, the otherwise, that is even on a single side. Okay. So that is, in that case, it is called as a coplanar arrangement. So which means, so this is the area to be treated. So here is one plate and then here. Okay, that is the two parallel plate or two electrodes. So what will happen? The two electrodes means, so just in a 3D view, you can imagine that if you have placed one plate and then one plate on the same side. So what will happen in this way? So this is the bone, if it is the area to be treated. that is there will be a two parallel plate that we have to keep like this. So what will happen now? The capacitance effect can be formed between these two. So now this is the area that can be treated due to the dielectric loss of the capacitor. So this is one method. So that is nothing but an capacitance method. The another method is nothing but called as an inductance method. So in the inductance method, the high frequency current is passed through a cable. So now what happened with the high frequency current? We are going to pass through a cable which can be wrapped around the area which we can treat. So what will happen? Because of it is wrapped around the area to be treated, now which can provide the effect of the coil. So which is nothing but this effect is called as an inductive effect. So now the high frequency current, that is the inductive effect. So there is the establishment of another magnetic field. Okay. So magnetic field, now what will happen? Magnetic field can induce electrostatic only. So that electrostatic here, that is due to how it is applied in the form of heat due to its eddy current loss. Whereas in the case of an capacitor, it is due to the dielectric loss. Here it is due to the eddy current loss. It is applied in the form of an heat to the particular subject. So in both the methods, that is either it is sent through the cable or otherwise by forming the two parallel plates, it cannot be done directly over the tissue or muscle. Either the tissue or muscle always should be wrapped around with some towel, and then over the towel only we are going to either form a parallel plate or otherwise we can send a high frequency current through a cable. So now the amount of heat what we want to think is being now transferred to the human subject, so that any swelling in the bone or in the tissue or underlying tissues now can be treated by adjusting the frequencies only. So this is the shortwave diathermy. So here in the shortwave diathermy, one thing is here continuously we are sending a high frequency current. So because of we continuously send a high frequency current, what will happen after some time? There may be a tissue burn. So in order to avoid this, shortwave diathermy can be applied in terms of some pulsed mode. So pulsed mode is nothing but just by giving a gap, which means some amount of time that we are going to pass a high frequency current. Later we are going to provide some relaxation, and then again we are going to pass the high frequency current. So here that high frequency current we can able to provide only 65 milliseconds. Say this is the high frequency current. So this high frequency current here we are going to provide for 65 milliseconds, and then the gap here it is an 1600 milliseconds, and then the next 65 milliseconds duration of exposure of a high frequency current. And moreover, that is this peak voltage. So this peak voltage is provided, what is the amount of power to be delivered to the particular subject. Okay. So here the maximum of here it is 600 to 975 volts, so that we can have maximum of here the 400 watts. So like in the pulsed mode, that is minimum of that is 80 to 160 pulses that we have to provide. So minimum pulse 80 pulses, but keeping the 65 millisecond pulse duration, 1000 millisecond is the half duration that we have to provide, and at the same time the maximum amount of power here can be achieved with 400 watts with a maximum of 600 to 975 voltage here we can able to use it. So that's all about the shortwave diathermy. So in the next class, let us look about microwave diathermy. So the microwave diathermy is basically one development is nothing but in order to overcome certain disadvantages which are exist in the existing method. So in the shortwave diathermy, there are some disadvantages existing. So what are those disadvantages and how we are going to overcome those disadvantages with the help of the microwave diathermy unit, that we will see in the next class. So for this class, you can take one small assignment. So these assignments just consist of simple 2 mark questions only. So you can find out the answer based on the lectures given and then submit. So the first question is, what is diathermy? The second one is, what are the advantages of diathermy techniques? Third one, define inductothermy. So the inductothermy is nothing but the inductor method only, the another name. Similarly for the capacitor, that is condenser method. Fourth question is, what is condenser method of shortwave diathermy? Fifth question, list out the various types of diathermy techniques. Give the frequency, wavelength and velocity of shortwave diathermy. I think this is sixth question. 7. In the induction field diathermy, the heating effects are done by using dash. In the induction field diathermy, the heating effects are done by using dash. Next, true or false. So in the true or false, number 1, the smaller the electrode, the more superficial and local the pattern of heating. The smaller the electrode, comma, the more superficial and localized the pattern of heating. Second one, the pattern of heating is changed by altering the relationship relationship of the electrode to each other. So the second one is, the pattern of heating is changed by altering the relationship of the electrode to each other. So these are the 2 questions under true or false. You submit your assignments through Google Classroom. Thank you.